Hello students, welcome back. Welcome back to the world of RoboBrain. So students, we have been discussing the chapter circular motion. Now let us start with the next interesting module of this chapter, circular motion. Yes, what we are going to do in this module? There you go. We are going to discuss the differences between UCM and non-UCM. That is uniform circular motion and non-uniform circular motion. This is a very, very important module. Alright, this question is directly asked in the state board. List the differences between UCM and non-UCM. Is that clear? So are you geared up? Okay, let me start the module. Now students, as I told you, in this module we are going to list down the differences between a uniform circular motion and non-uniform circular motion. The first difference. What is UCM? Yes, what is uniform circular motion? I'm asking you. What is it? Come on, speak a bit louder. Yes, correct. In UCM, the angular speed of the particle is constant. Is that clear? The magnitude of angular velocity of the particle is constant. That is your UCM. Non-UCM, very good. In non-UCM, the angular speed of the particle is variable. That is, the magnitude of the angular velocity is variable. Alright, angular speed is variable. This is the first difference. Fine. Second difference. Angular speed is constant, that is the magnitude of angular velocity is constant. Then I can say angular acceleration of a particle performing UCM is 0. But on the other hand, you see here, non-UCM, angular speed is variable. So then the magnitude of the angular acceleration of a particle performing non-UCM is not equal to 0. Alpha is not 0 over here, but there alpha is 0. Is that clear? This is the second difference. Third difference. Now students, we all know UCM is an accelerated motion. We have seen this in the previous module. Yes or no? Yes, we have seen. So UCM is a accelerated motion, and a particle performing UCM will have only one component of acceleration. What is that component? Very good. You have revised. A particle performing a uniform circular motion will have only one component of acceleration, and that component is your radial component of acceleration. So it will have only AR. So somebody may ask, sir, UCM, the linear velocity is constant, magnitude is constant. Alright, but keep this in your mind. The direction of the linear velocity is changing in UCM. And we all know linear velocity is a vector quantity. So even change in direction, there has to be an acceleration. Alright, so then a particle performing UCM, even though magnitude of linear velocity is same, since the direction is changing, it has only one component of acceleration called as radial acceleration. Radial component is there. Is that clear? Tangential component is 0. There is only radial component. Why? Because the direction of linear velocity is changing. We have seen this. Alright, so this is one of the differences. What about non-UCM? Non-UCM, the particle performing non-UCM will have two components. The radial component of acceleration as well as tangential. Both are present. But in UCM, we have only radial component, that also because of the change in direction of linear velocity. Is this clear? So this is the third difference. The fourth is you can give examples. Alright, example of UCM. Yes, wonderful. The motion of the earth around the sun is a uniform circular motion. Example of non-UCM? No? Okay. Example of non-UCM is motion of a body in a vertical circle. Now students, this is called as vertical circular motion. Alright, it is a non-UCM and we'll be discussing this in the upcoming module. Alright, so that's why I brought it over here. Motion of a body in a vertical circle is a non-UCM. Is that clear, students? So you have understood the differences? The main difference is your third one. In UCM, the particle will have only radial component of acceleration. In non-UCM, the particle will have both the components of acceleration. Is that clear? So if this question is asked in your state board, will you be able to answer? Okay, now you are confident. So, time for me to leave. I'll catch you up in the next module. Questions are very simple. You can do it. Okay? Rise and shine.